Great. So in this video, we are going to be talking about gases and their properties. All right, so the first thing we should talk about is what gases look like on the molecular level. The picture that we have of a gas is all the way on the end, right? So the picture we have of a gas is right here. And what we're saying in a gas is that molecules are moving very quickly and they are very far apart. The other component for a gas is that it does not have a definite shape and it has no definite volume. It is going to expand to fill the container. Again, those things to think about are how fast the molecules are moving in a gas, how far apart they are from each other, and then consider the fact that a gas will completely fill and occupy the container that it is in. Before we start to really dive deep into gases, it's important to go over the kinetic molecular theory because this gives us an explanation for why gases behave the way they do. Here are the important pieces of the kinetic molecular theory. First, small particles that are moving very randomly and quickly. That is what a gas is made up of, which we just talked about in the previous slide. When we are talking about an ideal gas, we are saying that the attractive forces are negligible. So if two gas molecules get close to each other and bump into each other, we're saying that they're just going to bounce apart, right? There's no attractive forces. They're not going to stick together. We've already talked about this too, that a gas will completely expand to fill its container. So the volume of a gas is equal to the volume of the container that it is in. Again, we talked about this. Those particles are in constant motion. They are moving super fast, right? And they're bumping into things. Like we said, they're very far apart from each other. And we've already talked about temperature before, but the average kinetic energy, the movement of those molecules, is proportional to the temperature. So as I raise the temperature, those particles are going to move faster. As I decrease the temperature, those particles are going to move slower. And then the last piece is to talk about the different variables that we can look at when we're talking about gases. And the first one is something we have not defined yet, and that is pressure. And you will always see pressure denoted with a capital P. Pressure is defined as the force per unit area. So as these particles, as these molecules are moving super fast in a gas, when they collide with something, like you or the walls of the container, they exert a force on that. That is pressure. Pressure is defined as the force per unit area. The units that we use for measuring pressure are ATMs, which is short for atmospheres. We have torr, millimeters of mercury. If you've ever put air in your tires, you measure this in terms of PSI, pounds per square inch. And then the last two are pascals and kilopascals. We may ask you to go back and forth between different units of pressure. Your conversions are, for every 760 millimeters of mercury, that is equal to 1 atmosphere, or 760 torr, which is equal to 101,325 pascals, or 100.325 kilopascals. So volume is a capital V. The units for volume will be in either liters or milliliters, and we've used those before. Temperature is a capital T, and this is critical. Every time we are dealing with temperature, when we're talking about gases, it will be in terms of Kelvin. And just to remind you, the conversion here to go from Celsius to Kelvin, you add 273.15. And then the last unit, and again, this is something we've already talked about, amount. The amount of a gas, we will be talking about that in terms of moles, and the symbol we'll use for that is a lowercase n.